Hey everyone, this is Matt with Learn Everything About Design, and in today's video, we're going to be doing another mechanical iris. Now, this design is the third in our series that we're going to be taking a look at. There is another one that I want to do, but honestly, there is an endless number of variations to these things. So the reason that we're jumping to this one is because this one is going to be an overlapping iris. The last two that we did were not overlapping, they just simply were actually meeting directly in the middle, and there are potential problems with that. We don't get as much coverage. Like with the last variation, we had it opening up, and this gives us a nice overlap between all the different blades that are going to be in this assembly. And this one's actually fairly simple to do. The math or the mechanics behind it aren't really complicated. And we did 3D print a variation of this one, actually this exact one here. And in the video, I'll give you some tips and ways in which you can customize this and make it your own. But in the end, we're really looking mainly at the mechanism here and how to set it up. So real quick, let's just take a look at how this works. We've got these individual blades. And when we take a look at these blades, they're fairly simple. They have a pin on the bottom side and a pin on the top side. Now, to 3D print this, what I did was I printed the pins separately, and I had a small hole here, and I simply pressed them in and super glued them in place. That way I could print a thin blade and not have to have a bunch of support and worry about damaging it. So the blade is fairly simple, and when we take a look at the design from, let's say, a front view, each of these blades, in this case, we're going to do 6 blades for this variation. Each of them pin on one side, so this top plate here just has holes in it. And on the bottom side, there are slots for the other portion of the blade to ride in. And this allows us to control basically what happens with that wedge piece when we start to rotate this around. So as we start to rotate it around, it starts to slide in that slot inward. Fairly simple mechanism. There's all kinds of variations. Instead of the slots being vertical, you can have them travel a different arc path if you want it to close quicker or slower, those kinds of things. But the main function or the main purpose of this is fairly straightforward. So in order to design this, once again, we're going to begin with a new untitled document with the metric units. I'm just going to use all millimeters in this case. Pick a plane, front, top, doesn't really matter. And then we're going to start with a circle. Most of these designs will start with a circle. And in this case, what we're going to do is we're going to make it smaller than our last variation, which was 100 millimeters. What we're going to do is we're going to pick the center line path for the pins in the open position. Now, this is one that we're going to design in the open position rather than the closed position, because this is going to help us determine how much that outside ring needs to be in order to hide everything. So I'm going to use, let's say, 58 millimeters, and I'm going to instantly turn this into construction. So X on the keyboard or click there, double click the mouse to zoom in and zoom out just a little bit. So this is going to be the center line of that arc. The next thing that we want to do is create a vertical slot that will be the distance that that one pin is going to travel. So create slot, and we're going to do center to center. Pick a point up here, drag it down. Don't worry about how far right now. And I'm going to make the pins for this one, because it's a smaller one, I'm going to make them 3 millimeter. And the actual pins that go in there will be a little bit smaller, probably 2.5, 2.75, depending on if you actually want to print this thing. Next, we need to make sure that this is vertical. It can be kind of hard to see with all these constraints and dimensions, so you can always toggle them off to make it a bit easier. So right now this slot is on the circle, but it moves left and right. So I'm going to select its center line, control select the origin, and make those coincident. This basically means that that line will always extend down here. So if we took this vertical constraint away and dragged it around, it would always point toward the center. So I'm going to select it, make that vertical again, then bring back my dimensions and constraints. So now what we have here is we've got that slot position. To make this easier on myself, I'm going to create a circular pattern. I'm going to double click the outside, and then I really just need this center point here. I'm going to click that as well. And this is going to be the number of instances that we want. Now, I don't know why this thing moves sometimes when we click it, but I'm going to create 6 and say OK. The reason that we want this is because the second location, the pin hole that's going to be in the top piece that rotates, that needs to be essentially tangent to this. And what we're going to do is we're going to traverse across 3 of these slots. So we're going to pin to the top here. We're going to move across this one, and then the other position will be just past this slot. So I'm going to use the circle tool. I'm going to basically snap until it's tangent there, and then hit D on the keyboard for dimension. And I'm going to make this 3.5 millimeters. Now, remember what I said, these are 3 millimeters. The pin that's going to go inside it is going to be a little bit smaller. The reason that this one is bigger is because I want a small gap between these. You could theoretically make them perfectly tangent because one's in the bottom piece and one's in the top piece, but I'm just going to leave a small gap. Select both of these, make them tangent. We basically want to fully define this. You can see it's saying it's not fully defined, but we can't actually drag it anywhere. So there's a coincident constraint here that we can get rid of, which lets us drag that. Basically what we want to do is kind of uncheck that, bring that back, then make these tangent. So sometimes those persistent constraints can be a bit of a pain. You just need to kind of work your way back and fix them. So we are going to need all the other holes, but we can actually worry about that later because it's just going to make this whole process more complicated. I'm going to double click this, hit X, and do the same thing over here. You don't necessarily need to do this, but it makes our selections a bit easier. So now what we have is the ending position for our wedge or our blade and the starting position. So we're going to go back, go to our slot tool, and we're going to do 3-point arc slot. So we're going to start at the center here. We're going to end here. And we want it to be equal to that radius value and then just drag it out right now. Now, if we start to drag this out, you can see it didn't apply that persistent constraint. So we want to select its center line, Shift or Control select this, and we'll make them concentric. Because the endpoints were already snapped to those locations, concentric will sort of bring it back in line. Now we can define the overall size of this wedge. And this is where we need to start to think a little bit about the math. And the reason I say that is because as this piece slides down in this slot, that's going to cover up the inside. So the larger number of blades you have, the thinner this can be. The fewer number, you're going to have to make it a bit bigger. You can play around with figuring out the area of this. So if you click on it, you can see down here the area is 1,094 square millimeters. If we make that not construction anymore and we select these here, with these profiles, what we can do is we can kind of get a feel for the amount of area that we need to cover. And then you could go, again, just think about the math behind it and try to figure out how big these blades need to be. But what we're going to do is a little bit easier than that. We're going to create a couple more circles. We're going to create an outside and an inside. Now, the outside, I'm going to make 75 millimeters. It's probably a good size. And the inside looks like it's about 42 right now, so we'll just stick with 42. So this is going to be basically the amount of area that we can hide or nest this into. So what I'm going to do is I'm going to make this outside arc, and this one here, concentric, which they are, and then equal. And that's going to fully define that sort of blade piece. You'll notice that there's a small amount of overlap here. Now, if we want to get rid of that overlap, then what we could do is we could make this inside diameter smaller, say 40 millimeters. And that would be perfectly fine. It kind of just depends on, again, whether or not you're going to try to 3D print one of these things, whether or not you're going to try to design it to be a certain opening size, and then you can play around with these numbers. So all you really need to do at this point is we've got our 58 millimeter diameter for the center line. As we increase this, say to 60, it's going to make that wedge piece smaller. As we decrease it to say 55, it'll make that wedge piece bigger. So once again, once you have this sort of rough concept, this base down, you can start to play around with the numbers and figure out what you need to do. But this is really all there is to the design, fairly simple. So what we're going to do from here is finish the sketch. We're going to extrude, and I'm going to extrude this blade piece, and I'm going to leave this hole open. Now, actually, you know what? Let's go ahead and fill it in. I'm going to do minus 0.4 millimeters. So if you're going to 3D print this, my suggestion is to do 2 layers if you're using like a desktop FDM machine. 2 layers. So if you have the first build layer at 0.2 or 0.28 and the second layer is 0.2, then make the overall height of this thing somewhere between 0.4 and 0.48. That way you've got 2 solid layers of traces being printed, and that will give you a pretty thin piece that you can play with, and then you can kind of work from there to see what works for your own printer. So 0.4 worked pretty well for my printer, and currently this is a body. I could have done that extrude as a component, so instead of new body, we could have done new component. Once you actually create that body, it won't let you do it. You have to convert it. Not a big deal. I'm going to rename this to be our blade, and then I'm going to start to create the other pieces. So we're going to hit extrude again, E on the keyboard. I'm going to fill this piece in, basically fill all this in, and the hole, and we're going to extrude this backwards. It doesn't have to be very big, 1 millimeter, and again, if you want to make it a component at this point in time, you can. It's going to create a new component. We can activate it, and then we can start to extrude those slots. So the back piece is where I'm going to put those slots. Just cut them all the way through, say through all. And then we're going to do a circular pattern, select features, pattern that. We're going to go around the y-axis because I picked the front plane, and we'll set this to 6. So that's basically the back piece. What I'm going to do is I'm going to add a small lever. Actually, you know what? The back piece is going to stay fixed. We're not going to add a lever to it. So we can go ahead and activate the top level. We can show our blade. The blade is now going to be a component. So we're going to create a component from body. We'll use that original sketch. And what we want to do now is we want to make the pins. So we're going to have a pin going down and a pin coming up. So I'm going to start, create a sketch. We're going to go to create, project include, and project that center point and this center point here. And then we're going to create circles. See on the keyboard, this is going to be 2.5 millimeter. Again, I'm leaving these to be pretty large gap. Again, if you're 3D printing it, you have to work with whatever tolerances your machine will do. I find that with these smaller bosses and slots, that leaving a slightly bigger gap helps, just because at the very end of these prints, they tend to sort of warp out a little bit. So leaving a slightly larger gap can be helpful. So now what we're going to do is hide the original sketch, E to extrude. This is going to go down, and we want this to go to join together with the blade. The distance you go really depends on what you want to happen on the other side. The way that this design works is all of these blades are stacked on top of each other, which means that the one next to this is going to be pushed up 0.4 millimeters, and so on for all 6 of these blades. So these pins actually need to be decently long to make sure that they all go into those slots. We'll bring that last sketch back, extrude, pull this one up. Let's just do 4 millimeters again, and then we can hide that sketch. So now we've got our base piece and we've got our blade. The last thing that we need is that front piece, and I'm just going to use that same original sketch again. I'm going to hit E to extrude. I'm going to select the profiles, and then this one's a little tricky because what we're going to do is offset this, and we have to think, we've got 6 blades. Each of the blades are 0.4 millimeters, and we need to have enough space. So I'm going to do minus 0.4 millimeters times 6. And that's going to give me my negative offset. And then this is going to be a negative, let's just say 1 millimeter, just so we can see it. And we'll make a new component. It looks like there's a small piece that I need to select for the profile. So let's just get that. That looks okay. And then we're going to do, let's see, extrude. So E on the keyboard, hold down the left mouse button and select our profile. Bring this all the way up through, but we only want to cut through that new component, not the blade. And while we're at it, we can activate that, make it a bit easier. We're going to circular pattern this feature about the y-axis, and this is going to be 6. And hide all our sketches, and let's make one more feature here. I'm just going to add a 2-point rectangle. Let's go ahead and let's use the center point. We'll make this and this horizontal. D on the keyboard, we'll give it 10 millimeters and let's just give it 25 millimeters. And then extrude this. We're going to go up to object, to the back side of this face and join them together. And that'll be good enough. All right. So now the fun part of adding all the joints and then patterning the blade. So we've got 6 blades that we need. So we can select the blade, circular pattern of components, once again about the y-axis. We'll make this equal to 6. And I'm going to hide all the rest of the blades for right now. So this back component, I'm going to call this my slot ring. I'm going to pin it. So that's going to prevent it from rotating. This front one I'm going to call the spin ring just because we're going to spin it. And that one needs to have a revolute joint so it can freely spin about. So we're going to go to Assemble, As-Built Joint, set our type to revolute. And between this piece and that back slot ring, we're going to have it revolve about its central axis. Then what we're going to do is we're going to hide the spin ring for right now. We're going to go to our as-built joints, still revolute. Between this and that spin ring that we just hid, we don't really need to see it because we have the revolute position based on that pin. And then I'm going to rotate this around. And I'm going to do my right-click as-built joint. This time we're going to do a pin and slot. Between this blade component and the slot ring, we'll select here, but we need to change the slide axis to Y so that it's going the correct direction for that slot. And now if we bring the spin ring back and we rotate this around, we should be able to start seeing that motion. So again, the size of everything here is going to be dependent on a few things. You can kind of see here, we can't quite get this wedge piece all the way to the center because it leaves this gap right here. And that's okay because honestly, these things overlap. It's never going to be able to perfectly close in the middle. But this gives us an idea about how much coverage we have with just one of these blades. So you could theoretically use just 3 of them and pretty much cover the entire thing except for right there in the middle. But that gives us a good idea to make sure that the motion is working. Now, the easiest thing that I found to continue to add these joints is to just hide the blades that you're not working on and do an as-built joint on the blade you are working on. So we're going to go between these two, pin and slot, change it to the y-axis, say OK, right-click to repeat. This time we're going to do revolute between this and that spin ring that's hidden, and then pick that pin position. And then I'm just going to move my way down. Because my last joint is going to be revolute, this time I'm going to add the revolute first, then I'll right-click and repeat, and then I'll do the pin and slot. It seems to be the quickest way for me. It still does take a bit of time, and if we were to add 10 of these blades, then you're just going to add more time that it takes to add these joints. But with a little bit of practice, it doesn't really take that long. I will say I did have a comment asking about copying in terms of patterning these with the joints. There are some things that we can do if we've got sub-assemblies and joints between multiple components. As far as what we're doing here, there is no way that I know of to allow us to pattern these. There is a duplicate with joints option that's up here. This only works for sub-assemblies that have joints created with the joint option, not the as-built joint. A part of the reason for that is as-built joint makes use of the current position or location of your component. So we don't actually have to select a position on the component to relate them together. And because of that sort of missing piece of information, it's not able to do a copy with these joints. So unfortunately, there's not really a quick way to do this. You just kind of have to work your way through it. The good news is that once you do it once, it's not too bad. You can use the right-click marking menu, and you can kind of speed through this. This is the last one here, revolute, this and our spin ring. And there we go. If we bring all of them back, I'm going to hide the joints on the screen. This top piece, I'm going to right-click and make it go to 30% opacity, so we can kind of see what's going on inside. And again, that is it. That's the entire mechanism. Now, in reality, we left a pretty big gap because when you assemble this, again, all these blades are going to be stacked. That's kind of the nature of how this thing works. So if you're going to design something for 3D printing, so if we just take a look at this design here. So this is the one that I did for that short video. I left the blade in the middle, so all the blades are in the middle, but I did account for the amount of space needed, and I have a little sort of snap feature to hold the two pieces together. It's not great. It works for a demonstration video, but if you actually want to make one of these things where you can print it and it's pretty robust, you do need to put a little bit more thought into how all the pieces are held together. There are some great examples online of how people have done this. So, for example, instead of this top ring being, sort of the outside here with this sort of lever on it, you can put a boss here that you can move left and right and have a trim ring that snaps over the top of this. You can glue pieces together, of course, but I would just caution you to leave enough space on the inside. If you need exactly 2 millimeters of space for all of your blades, leave a little bit of extra because they do tend to bind up because they are sort of overlapping each other. But that's the basis for this mechanism. As I mentioned, this one is pretty straightforward compared to some of the other ones that we've done. The last one that I do want to cover on this channel is closer to the aperture that you would see in a camera. The blades operate in a similar fashion, but they're pinned on the same side, and the ends of them are sort of free floating in the middle. It's a much more complex mechanism in terms of figuring out the shape of each blade. This one is probably the easiest one out of all the ones that we've done. But if you have any questions on this, or if you do end up making this design, please leave a comment, let me know, and I'll do my best to try to answer those questions. As always, thanks for watching, and we'll see you in the next one.